Vectors. We'll practice O-level maths past exam paper questions about vectors from the series May-June 2023, Paper 2, Variant 2. Let's begin. So, May-June 2023, Paper 2, Variant 2. And the question about vectors is question number 10. It says, F is the point 6, 1 and G is the point -2, 4. So we are given 2 points and we are given one vector. The vector GH, it's -1 and -8. And the question tells us to calculate the length of the vector FH. So these two lines mean the length of the vector, and to calculate the length we have to use the distance formula. So the length of the vector FH will be equal to x1 minus x2 whole squared plus y1 minus y2 whole squared and the square root of this entire thing. And in the vector FH, the starting point is F and the coordinates of F are given to us in the question 6, 1. And the ending point is H and the coordinates of point H are not given to us in the question. So the coordinates of H are unknown and we can find out the coordinates of H using the vector GH. In the vector GH, G is the starting point of the vector and H is the ending point of the vector. So the vector GH can be broken down. It can be broken down into its position vectors. The ending point of the vector is H. So first we write the position vector of H, OH. Then the starting point of the vector is G. So after that we write the position vector of the starting point G, minus OG. That is how we can break a vector down into its position vectors. Now we have to find out the coordinates of point H. So we make the position vector of point H, the vector OH, the subject of the formula. So OH will be equal to the vector GH plus the vector OG. I have moved OG to the other side of the equation and I get plus OG. And the vector GH is given to us in the question, -1 and -8. So in place of GH, we can write -1 and -8. The vector OG, the position vector of the point G, will just be the coordinates of the point G. So -2, 4 are the coordinates of point G. So the position vector OG will be -2 and 4. So in place of the position vector of G, the vector OG, we can write the coordinates of point G that are -2 and 4. And we can add these two vectors to get the position vector OH, -3 and -4. This is the position vector of the point H, and from this we can get the coordinates of the point H. That will be -3, -4. So we have the coordinates of the point H, -3, -4. Now we can use this in the distance formula to calculate the length of the vector FH. If F is 0.1, then its coordinates will be x1 and y1. And let's say H is the point 2, so its coordinates would be x2 and y2. Now we place these values into the equation. x1 is 6 and then there is the minus in the formula, and x2 is -3 whole squared plus y1 is 1, then the minus in the formula, and y2 is -4 whole squared and the under root of this entire thing. So we get 6 plus 3 whole squared plus 1 plus 4 whole squared, under root of this entire thing. And we get the under root of 9 squared plus 5 squared, that equals under root 106, and that is 10.29563. So we can write it in the answer space. 10.3 units is the length of the vector FH. Next, the question gives us a diagram with some points and some vectors, and it says the vector OA is equal to A. So the vector OA that starts at point O and ends at point A is equal to A. So this vector that goes from O to A, its name is small letter A. And the vector OB is equal to B. So this vector that goes from O to B is small letter b. And if the vector OB is equal to B, then if we reverse the direction of the vector, we start at B and go to O, that will be the vector BO. The direction is reversed. And if the vector OB is equal to B, then the vector BO will be equal to -B. So if the direction is reversed, the sign of the vector is changed. And we will use this later in the question. Next, the question says the vector AC is equal to K times B. And X is the point on OC such that OX is equal to M times OC. And in the first part, the question asks us to write the vector OX in terms of M, K, A, and B. Now let's see how we can do that. So we will use this equation that is given to us. The vector OX will be equal to M times the vector OC. And the vector OC is this vector that goes from O to C. And we can break this vector down into two other vectors. This vector that goes from O to A, the vector OA, and this vector that goes from A to C, the vector AC. So the vector OC is equal to OA plus AC. And we are given in the question that the vector OA is equal to A. So in place of the vector OA, we can write A plus the vector AC. And we are also given that the vector AC is equal to K multiplied by B. So in place of AC, we can write KB. So the vector OC is equal to A plus KB. And we can place this value of the vector OC in place of the vector OC. And the equation becomes the vector OX is equal to M multiplied by A plus KB. So OX is equal to M times A plus KB. Next, the question gives us a vector BX. That is this vector that goes from B to X, the vector BX. And we can break this vector down into other vectors that are given to us. So this vector that goes from B to O, the vector BO, and this vector that goes from O to X, the vector OX. So the vector BX can be broken down. BX is equal to BO plus OX. Now we are given in the question that the vector OB is equal to B. And that means the vector BO will be equal to minus B. If the direction of the vector is reversed, the sign changes. So the vector BO is equal to minus B. So in place of BO, we can write minus B. And we already have the expression of the vector OX from the first part. So the vector OX is equal to M times A plus KB. And the question gives the vector BX is equal to 3 by 5A minus 1 by 2B. And that is equal to minus B plus M times A plus KB. Now let's move this over here so we have more space for working. First, we multiply M with this bracket. So we get 3 by 5A minus 1 by 2B is equal to minus B plus MA plus MKB. Now we collect the like terms. These two terms contain B, so we collect them together. 3 by 5A minus 1 by 2B is equal to MA plus MKB minus B. Now the last two terms both have B in them. So we can factorize this B. We can take B common from these terms. 3 by 5A minus 1 by 2B is equal to MA plus MK minus 1 times B. So we have factored out the B from both of these terms. We have taken B common. Now if we compare the left and the right hand side of the equation, we have A over here and A over here. And the coefficients of A will be equal. So 3 by 5 will be equal to M. And we get the value of M, that is 3 by 5. Next we compare the coefficients of B. We have B over here and B over here, and the coefficients would be equal to each other. So that means MK minus 1 is equal to minus 1 by 2. Now we can place this value of M over here. In place of M, we can write 3 by 5. And we can move this minus 1 to the other side of the equation and we will get plus 1. So 3 by 5k is equal to minus 1 by 2 plus 1. Minus 1 by 2 plus 1 will be equal to 1 by 2. So 3 by 5k is equal to 1 by 2. We move 3 into the denominator on the other side and 5 into the numerator on the other side. And we get 1 by 2 multiplied by 5 by 3. So k is equal to 1 by 2 multiplied by 5 by 3. And that means k equals 5 by 6. So the value of k is 5 by 6.